All right, welcome back, everyone. Of course, this is Math 21. We are starting chapter 3. Chapter 3 is on the numerical summary of data. And 3.1 is on measures of central tendency. So recall our 4 distribution shapes we talked about at the end of our last lecture. We had a uniform distribution. We had skewed left distribution. We had a skewed right. And then a bell shape. I got a graph of each of these, like examples. So uniform, like the columns on our histograms were all the same size. Maybe a little variation, some were taller than the rest. Skewed left, we had a tail on the left. And as we went to the right, there could even be a gap. But as we got to the right, it got bigger and bigger, and there was a big old hump on the right. But there's a bunch of little shit on the left. Skewed right was the other way around. We have a big old hump here in the middle or on the left. But as we go to the right, we get more and more little stuff down here. And bell shaped, I'm going to do a little sketch here, and then I'll do it with the curved picture without boxes down here. Bell shaped, kind of like the center is about the same height, and as we go left or right, it decreases about the same amount. Some sides may be a little bit more than the other, but the idea is if you put a curve over it, covering like you draped a blanket over the top of it, the blanket's gonna sit like that, which is in the shape of a bell. Put my little red curve over here. So this is on central tendency. Where is the center? Did we go for the pictorial center? Like just do the middle of the graph? On the uniform, I would say the center is right there, and that I can get away with that. If I look at the data, the same amount of data is on the left or the right. Things like that. Center isn't all that helpful on uniform. On the bell curve, it's kind of easy to find as well. I would say that's the center. It's the middle of the hump. But what about skewed left and skewed right? We're gonna come back to skewed left and skewed right, and we'll come back to this page. To the skewed graphs. And the reason why is like if we try to do like the center of the picture. Well, like on the skewed left, I got very small boxes on the left, tall boxes on the right. That don't seem balanced. That was a teeter-totter. The fat kids are winning that motherfucker. I can say fat kids, I'm fat. Be nice to other fat people, folks. Skewed right, the same thing with the left side. So like putting it in the center of the picture doesn't help, but if I put it in the center of the hill. Well, now it looks like there's a whole lot more shit on the left on this. So we're gonna come up with a way of devising what we use for the center here. But we gotta talk about some math shit first. I'm gonna point out something else here before I change pages though. On the bell-shaped graph, I could have a bell shape that is lower here, but taller on the edges. Or I could have a bell shape that's lower on the edges and kind of spikes up in the middle. So like, if we know the center of the graph, knowing the center doesn't show everything. Doesn't tell us everything. Is the graph tall? Is it short? Because remember, on a histogram, these curves go over the boxes, but the boxes represent the number of people that said that same answer. So like on this bell shape, whatever these numbers are, a lot of people said those answers. Twinkle, twinkle. You guys ready for more? Does anyone need this up longer? You raise your hand, like I'll see that more than hearing a muttered word. All right, so let's talk about mean, median, and mode. For the mean, we'll start with the mean. First off, we have two symbols we use. X bar is for the mean of a sample. Called the sample mean. And mu, which is, it's a Greek letter, pronounced, it sounds like MEW. This is a population mean. But what it is, the average of the numbers. To get the mean of a sample, we add up all the entries. And then we divide after adding divide by total number of entries. You will see this represented as this. That big letter is sigma, capital sigma, Greek letter. It means add up whatever's after it. Add up the shit after it. XI is your I data entry. So between the two, putting these two together, that is how that means that. Add up, that's my sigma. Add up all is that, and then the XI is this. N is your sample size. Or number of entries in the sample. Capital N is reserved for population size. We are going to see lowercase n and capital N all fucking semester. Get used to the little one being sample size, the uppercase one being for the entire population. Bianca, it's in my lab. The first set is due on the 10th. It was due already, but people didn't do it. I extended the due date. You gotta look at it in my lab map. Answering when is homework due is vague because there's homework due all semester long. After I cover a lecture, you got like basically a week to do the homework on it. All right, so in the support course, we started doing a list of like person number and then number of siblings, which is like brothers or sisters. Bros or sisters. And first person said 2, the second person said 2, the third person said 6. I have 1. I'll add myself on the list. I have 1. So calculating X bar here. We add up the values. That's step 1. Step 2, divide by total values. Total entries. So pictorially, or like writing out this, I would be adding 2 plus 2 plus 6 plus 1. And then dividing by 4. This is 11 over 4. Which is 2.75. If you have your calculator with you, try this. Try doing 2 plus 2 plus 6 plus 1 divided by 4. And tell me what you get. $10.25. If you do this on your calculator, it's gonna say 10.25. Because It's only doing division by 4 on that one. You really want to add them up first, hit equals, find the total, and then divide by the total number of entries. But I want you to see that you get the wrong answer. So like you can fuck it up, and a good way to tell that you fucked it up. Is that this is the mean or the average. 10.25 is bigger than every single entry on this list, so how could it possibly be the average? I assume everyone in here knows what the word average means. We use it enough in sports and throughout things that. So like if the number is bigger than all the other numbers, it's not the average. That's a dead giveaway that you fuck something up. Now, you can do this in the calculator. If your calculator has parentheses, you could do this same thing in the calculator, putting parentheses around that first. And then you should get 2.75.
Go ahead, try it.
You got it?
Try it.
You're only gonna be doing it by hand. If you wanna do it faster, when there's only like a few entries like this. Like 4 or 5 entries, other than that, we're gonna show you how to do it in Stack Crunch. It just takes longer to type all the shit in the Stack Crunch and do all that shit, load Stack Crunch. It takes some time, but it's easy to do in Stack Crunch. For a small number, like sometimes the home problem only has a couple entries, it's just easier to do the shit on your calculator. But we'll look at that in a second. We're gonna just do like a full lecture here first. Everybody ready? All right. So that's me. Median. If you've driven on the freeway. You've seen the median on the road. What's the median of a road?
The divider,
It's the divider. Where's the divider?
the middle.
It's in the middle. It's the middle. So. Our same data set, 22641 or 2261. We don't want to do it in the order it is. For the median, the middle, you need to sort them first. Sort them in order. It doesn't really matter if you go large to small or small to large. Most people do small to large. But if I put them in order. Hey Cosmo. When you coming?
Probably next week, I'll send out invites,
Okay,
I've been swamped, but definitely,
just reminding you,
yeah, sure. Have a good weekend.
you too. He's got a cool name, Cosmos, that's a cool name.
His last name, right?
No. Fuck, what is Cosmos' last name?
Great.
Alright, so basically finding the middle is going in one at a time. If you get it where it's not pointing at a number in the middle, what you're gonna do is you're gonna take the average of the middle two. This is what happens when there's an even. When n is even. Even sample size. So in this case, if I average the middle two. I'm just taking those two and I'm dividing by 2. 4 over 2 is 2. If they're the same value, the average is just those numbers. If n is odd. It's the exact center.
That piece in green is how you find the average. You add the two together and then divide by two, is that what you said?
Yeah, that's what we just did for the mean on the previous side.
Yeah.
But you're just doing the middle ones. So Alfredo, were you the one that said like someone had 13 in their family?
No.
Who said that?
Oh, my mom's like. Great.
So mom had 13 siblings. So like if, let's say we add, let's add 13 to the list. Now, if I put them in order. 1, 2, 2, 6, 13. I can count in one at a time. And I just got a single number in the middle, so the median is 2 here also. What would happen to our mean with this? By adding someone with 13.
Make the average go up.
Let's recalculate. We're gonna do 1 plus 2 plus 2 plus 6 plus 13. And now there's 5 entries. I am getting X bar is 4.8 now. And what used to be 2.75, wasn't it? So this actually illustrates like 2 ideas at the same time. A number that is vastly or drastically larger or smaller than the rest. We could say further in value, just to summarize it, either direction. Further in value by a lot. Or different in value, there we go, I like that better. Different in value by a lot. That is called an outlier. I would argue that 13 is drastically different than 1, 2, 2, or 6. It's like double, over double the next lowest number. And also leads to another idea. Resistance. A calculation or summary, something like that. Is said to be resistant. If outliers don't affect it much. It can have a little effect, sometimes it'll have a little effect. But we don't want it to have a big effect. So like, let's talk about our data sets. We had 1, 2, 2, 6. And then 1, 2, 2, 6, 13. Our mean X bar here was 2.75. And our median, which we usually use M for. Was 2. And over here, when we did it, we got 4.8. And M was 2. Be careful with M if you go into the social sciences. They often use M for mean. So you gotta pay attention to how they use the terminology. Since this is the field of math, I'm going to assume mathematicians are correct. And the social science people are wrong. But it's just another notation. So, can I say either one of these is resistant? Is the mean or median resistant to outliers? Or neither or both? Did the value change by a lot by the addition of the 13? Well, median definitely not. Median didn't change. So median is resistant. What about the mean?
Not too much.
If you think about it in terms of like money, $2.75 and $4.80, it's not that much. But 4.8 is like almost double 2.75. And in this case, what if I had made it 100? Think about what happened if we had 100 here. This is gonna be a pretty big number, right? Because we're dividing by 5. It's gonna be over 20. The mean is not resistant to outliers. Two point seven five, 4.8 doesn't look like a lot, but it is. In terms of amplitude or scale. Another way of looking at it is, let's say we were talking about income. Annual income in here, let's say annual income. And we got our annual income, and then in walks fucking Elon Musk. And then we start talking about annual income again. Now, all of a sudden, the average annual income with Elon Musk in the room is probably, we're gonna say, millions. I don't know how much he makes a year, but I gotta assume it's like in the 100 million range or some shit like that. So I'm gonna say it's in the millions. But no one in this room besides him makes anywhere near that much money in a year. So like, the mean is drastically changed by his presence. It's also a good example of why we like to choose median over mean. We're gonna go back to our picture in a second, but since the median is resistant and mean isn't. It's not. We like to use the median. For the measure of the center. It's called central tendency.
That just for this example, or is that like,
This is for. For numerical data in general. So let's go back to our graphs. I want to make sure everyone's done writing on this page before I flip back. Everyone done? So conveniently for the bell curve. The center is the same thing as the median. And it's the same thing as the mean. The mean is usually actually easier to calculate. The computer, whether you know it or not, can calculate the mean faster than the median. Because all it has to do is add it up and divide. Now, when you look at it visually, the computer, to your eyes, does it in a fraction of a fucking second. But if you had like 10 million entries, like you're working with Facebook's data set, which is probably way bigger than 10 million. Adding things up is a lot quicker to do than sorting them in order. That takes a lot of time, believe it or not. But they're both equal to the same thing here. So that's both X bar and M. On the skewed graphs. The median is closer to the hill than the mean. And in some cases, a lot closer. Like just a quick sketch of that. I'm off the screen. If I did a little graph of our income thing that I was talking about. Here we are. And then Elon Musk is way the fuck over here. And the median is still near the center of the hump. But the mean is gonna be like over here. So we prefer the median. It's closer to the center. It's a better measure of the center. Now. Conveniently. When we start doing hypothesis testing. We will do it in a way. With processes. That allow us to use the mean. But that's like, I don't know, like chapter 9 or 10 That's after the midterm, that's a long ways away. And we're gonna give you like. Deciding whether this was the 13 was deciding that this was an outlier, the 13 was an outlier. When we do 3.5, you're gonna learn a better, like a way to like figure out what is classified as an outlier. We're gonna have a math process, computer's gonna do it for you, but we're gonna do it by hand too. Once so that you understand where it's coming from, it's something called the box plot. But outliers show up. And you'll see them. And you'll be like. You won't have to go, is this causing resistance or is 13 an outlier? We'll see it. We have one other category we wanted to talk about, mode. I said mean, median, mode. Is everyone down with that page? Okay. The mode. Is the most common response. And we must. Use it for qualitative data. Cause like, let's say we're talking about hair color. What the fuck is an average hair color? Like, we don't just mix the colors and say what comes out, cause that would be brown no matter how much color you had. You have one purple and a bunch of fucking yellows and it's still gonna look brown. So you can't do like an average on qualitative data. Median doesn't make sense, cause how do you sort hair color? Do you do it like alphabetically? Do you do it by brightness? You know, but there's no clear basis for sorting it. So we use mode for that. Conveniently on our data, we had a mode. The mode was 2. Simply because it showed up the most. And if we had 3s there, 1, 3, 3, 6. The mode here. Is 3. I wanna make it clear it's the number, not how many times it shows up. This shows up the most, there's 2 entries. That have a 3. Everything else has 1 entry, so it is the most common answer. So 3 would be the better. Mode for hair color is usually brown. But in the among the right populations, black is the next one. And only in Ireland could you probably get away with red. Irish have a lot of red hair in their genes. Freckles too.
Will we ever have like even entries?
What do you mean?
Like if you have 2 numbers that are or have the same frequency, like they show up the same?
Oh, like 2, 2, 3, 3, 6?
Yeah.
Yeah. So when this, I was getting to that. I'm glad you segued right into what I was gonna say. So if we have 2 that have it. Have the same frequency. And it's the highest. We actually call this bimodal. And you could say mode is 2 and 3. But generally, we're not gonna do a whole lot with mode this semester. It's more of a, you just need to know that it exists. If every answer is unique. We say that there's no mode. No one gives the same response as anybody else. Like if people gave their honest weight, this is probably be the case. Like if they just like everyone weighed, scales will do like a decimal place. So even if two people said 125, one is probably 125.3, the other is like 125.6, they're not the same. And then if there's more than two. We just call it multimodal, and that's, we leave it alone. And now the good shit. In StatCrunch. Or a C. We are gonna do stats. Summary stats. Columns. It will show rows. You can do the same thing in rows, but like doing rows usually doesn't make sense because generally we have like different people representing each row. And like a column is all the same question kind of thing. In here, we will select the columns we want. B, it's in the stats box, called the stats box. Select the stats we want. And C, click compute. And we're gonna do a lot of shit with this summary stats thing. This is the same command we're gonna do a lot for in chapter 3. Mostly chapter 3. And you'll forget about it later on, but we still can use it, people will forget, and I'll have to remind you. You get all that shit in summary stats, because you won't have done it for a while. Everyone ready to take a look at it on the computer? And let me change what the home viewers see. I'm in my lab, I click on StatCrunch, it gets me to this thing here, I'm gonna visit the StatCrunch website. Let's see, if you click on data sets, let's see what's. Movie budgets and box office earnings should be the top for everyone, it's the top every time I've seen it. Let's play around with theirs, let's take a look at what they got.
Data sets.
Holy shit, how big is this thing? Oh my god. 5,222 movies are on this motherfucking list. I haven't even heard of some of this shit.
And Avatar's the first one.
So how are they sorting it here? So domestic gross and world. It looks like they're doing it in order of what movie has earned the most. This list has been sorted. So like, it doesn't make sense to do an average for movie names, right? That seems stupid. Month, day, year must be release date, I'm guessing. That seems like a weird thing. Let's find the mode on release month. So we're gonna go stats, summary stats, columns. And I'm gonna tell it, I wanna look. Oh, it won't let me do month. How rude. You can't even get, well, that's rude because mode is on the list. They won't let us do qualitative data in summary stats. So we'll do month another way. But while we're here, let's do the average gross income and median gross income. Let's base it off domestic. So I'm gonna click on domestic gross right here in the columns. And down here, a bunch of them are already selected on the right. You can go with it as is, because the mean is usually on the list, but you're gonna have to look for it. Or you can come over here and just click on the one you want. If we click on the one we want, we'll see that the average domestic gross income is 43.5, M I think is in millions. Let's do that again where we put some more stuff on there. And maybe let's look at gross and then worldwide, domestic and worldwide. Oh, fuck it, let's add in budget too. And let's do mean. And then I scroll down, I'm gonna control click median. I'm gonna scroll down, I'm gonna control click mode. So that I can get all three at once. Remember us talking about control click or command click on Tuesday? I'll click it here. And it looks like there was no mode for gross or either of the grosses. But $20 million budget seems to have occurred more than any other budget. That's interesting. The average of the gross for domestic was 43.5. The median was only 19. And the mean and median are different, a lot different on worldwide too. If we do a histogram of these. Let's see. This is in budget. Apparently, most movies are made for less than 25 million, at least on this list. 5,000 can't be every movie made. That doesn't seem realistic. And this, so what type of graph would we call this graph?
Bar graph.
That's well, it's Instagram, but I skewed, no, right. So if you thought left, it's probably because you see the big shit on the left. You're like me. You're just gonna have to remember that you're fucking wrong. And it's the other way around. That's what I do. I look at it, I go, this is skewed left. Nope, that's wrong. It's skewed right. I do it every time. If we look at the domestic graph or domestic gross, it's the same way, and so is the worldwide. In fact, it becomes even more and more skewed. Like these at least tapers down slowly. That tapers down faster, and like worldwide, it's just like bam. Most movies didn't make, well, I don't wanna say didn't make shit, because 125 million is a lot of money. But like this is between 0 and 125. There was 5,200 something entries here. 4,101 of them made less than 125 million. So when they're like the top box office things and you're looking at like the 8 million and shit like that, there ain't that many. What movie made that much? Oh, Titanic. How is Titanic still near the top? Star Wars episode what? Oh, the newest one, or not the newest one, but of the new ones. I'm surprised Avatar's still in the top, seeing as how old it is. Generally, movies. What?
They went cheaper over time.
The fuck they have? What movie theater are you going to? Movies have gotten more expensive.
Yeah,
So like if you had the same number of tickets, like 1 million people bought it at $9, that's $9 million. And then 1 million people bought it at $15, that's $15 million. Like, as the ticket price goes up, you would think that the box office earnings. We shouldn't see newer ones, but like. The most recent one in the top 5 is 2015. I wonder if they just got a shitty list.
The information is probably wrong because Iron Man 3 was made in 200 or 180. So I don't trust any of that info.
You're right, that is an error. It's probably 2010 and they didn't do the zero. But it does show us how to use the summaries, the stats, summary stats columns. And that's what we're doing here, stats, summary stats, columns. Now, if you want to do the mode, you're better off just doing a bar plot. With data, we have the data. And now I can look at the month and we can see like which month it was the most common. And surprise, surprise, it's fucking Christmas. December. They know people are gonna be home for the holidays, they wanna do shit, go to the movies. Kids have time off, people take time off work, more people go to the movies in December than other months. I'm surprised it's fairly balanced out for the rest of the months. I wonder why October's so high, is it all the scary movies
Yeah, probably,
for Halloween?
yeah. I always go to movies in October. But never any other month,
Really?
me personally.
I call bullshit. There's no way you only go to the movies in October and no other month.
That's when every new scary movie comes out,
And you only watch scary movies?
in the movie theater specifically, kinda.
You don't like action movies in the movie theater?
I mean, I guess, but I can stream it, it's like, as a horror movie, I feel like it gives a different effect.
See, for me, a scary movie is worse at home. You can make it just as dark. That fucking house is empty too. Or now any fucking sound you hear. Might be something happening, whereas you hear another sound in the theater, you know it's someone else in the fucking room. But you can make that, all right, shit, we need to take a break, let's take a break. Let's take a 5 or 10 minute break. On. Something else I want to show on the screen, the histogram. If you bring up the histogram, you can click markers. For mean and median. And they show up on the graphs. So the green is the median or mean and the red is the median. And you will see the red is always closer to the spike, usually in the spike. The median's further to the right. Oh, they're both in the spike here. They're both there. Huh. All right. Back to our regularly scheduled programming. Other things, so let's do a couple data sets real quick. I want you guys find the mean of these two sets. Set A is 46, 48, 50, 52, 54. And set B will be 10, 30, 50, 70, and 90.
The random numbers that you pulled.
No, they're not.
No.
In fact, I'll give you a third set. Let's do 10, 49, 50, 51, and 90. Let's do 3 sets. Find the mean real quick. This is an exercise practice on the mean real quick. Maybe I should make it say 3 sets now. As a reminder, you're just adding them up and dividing by the total number of entries.
So we're finding the mean for each of the sets or all together?
Each set individually.
Okay, thank you.
Alfredo looks like he doesn't like what he got.
Oh, it's here.
They are all the same number. You should have gotten 50 for each of these. Now, if I were to do these on like a number line from 0 to 100. Set A is like, well. That's like set A. Set B is all over the fucking place. So the red will be set B. And like set C, we had one way out there and had one way out there. But then it had 3 right near the center. So these are like set C, they're kind of like clumped near the mean. And these other 2 I would describe as evenly spaced. If I were to, it's not a stats word, but they're all like roughly the same distance apart. Within their individual sets. But set A, if I did the smallest number to the lowest number, that's A. And then B and C both do. B and C are both those. And yet we got the same average on all of them. Clearly. And the same median if we wanted to do median, the median is 50 as well. Clearly. While the mean or median is important. it isn't enough to give a good summary of the data. It'd be like trying to summarize an entire movie with one word. How would you summarize the movie It? Some people might say clown. Some people might say horror. Some people might say Pennywise. But none of them paint the picture of what it is. Right? Need more than that. So that's where 3.2 comes in. 3.2 is on something called dispersion. Dispersion is how spread out is the data. Where the hell do you think you're going?
I just got a text that my dog just got hit.
Oh shit, I tried to be funny and that fucking. Dude, that sucks, I think that's right.
It's all right. I think he's been hit a couple times.
Is his name Lucky?
If I'm being honest. There's been a lot of traffic, but who knows?
That's
Yeah, it's all right.
you
So
would think,
we'll go to the vet and see how
you
he.
think this dog would fucking learn to stay away from vehicles if it's been more than once.
You would assume so, that he's a pretty stupid dog.
Or I don't wanna make a joke about it.
Now, please do.
Like if maybe there's a head injury the first time, he doesn't fucking remember, but. Lucky is a good name if he keeps walking away from it.
I have to change it.
But what kind of?
It's we don't really know. It's kind of a mud, but it looks
How big?
like a German short hair. Kind of.
Is it like a medium sized dog, short dog, small
Yeah,
dog?
pointer looking dog.
Okay. Your dog's all right.
Thank you.
I'll try and make a joke and it just fucking shut that shit backfired quickly. Right. Yeah, you don't see a fucking train wreck like that very often, Jesus. Alright, so spread out. I would say B is spread out much more than A. And so that's what dispersion is. Just how spread out is the data. And we have different ways of measuring it. Another way of calling this spread, dispersion or spread. Another idea is how much does the data differ or deviate from the mean? Everyone done? All right, so one option is called the range. The range is the largest number minus the smallest number. On set A, we had 54 minus 48 was 8. Set B, 90 minus 10 is 80. Set C was also 90 minus 10, which was 80. So B and C had the same median, mean, and range. And yet still they look quite a bit different. So range isn't the best choice. Notice like if we added like let's change set B to be 10, 30, 50, 70, 90, and then 210. Then the new range is 210 minus 10, which is 200. So range is not resistant to outliers. It changed a lot. So what we're going to use is, for most things, many things, standard deviation. Sometimes just called deviation. For examples, we use the letter S. And if you were here for the sport class, we saw this equation already. It's fucking atrocious. Populations. We use this character. This is a lowercase sigma.
Sigma. What is the sigma mean again?
What?
What does the sigma mean again?
In this case, it's gonna be standard deviation. The uppercase one was add shit up. This one looks like an O with a tail on it. The mu looked like a U with a tail on it. The formula is slightly different. It is xi minus mu squared, and now it's just over big N. So in both cases, xi, we mentioned this earlier, individual data entries. The X bar or the mu is the mean. And N or big N is the size of the group. The big E was capital sigma. And that means add shit up. And we use this most often for bell-shaped graph. Most often for bell-shaped graph. I'm gonna walk you through an example with set B, 10, 20, 30, 50. Or, well, let's make them smaller, let's do 10, 20, 30, 40, 50. If you find the mean here, you're gonna get 30. So the way this works, I'm gonna make a little table, I'll list my entries. This gives you an idea of what's going on. So these are my xi here. My x bar was already 30. I'll make a column for xi minus x bar. So here I'm doing 10 minus 30 is negative 20. 20 minus 30 is negative 10. 30 minus 30 is 0. 40 minus 30 is 10. What are you guys doing back there? I keep hearing perpetual sound from the back row. Like, if I can hear it, the students in front of you, you've gotta be hearing it, because you gotta be distracting the people around you. Can you please tone it down? Like maybe less. To be fair to them. I can't hear what you're saying, but I imagine people that are closer to you can't, so you're disturbing them. Alright, now we did this part, we did the subtraction, now we're gonna square them. So xi minus x bar squared. I'm doing negative 20 squared is 400. I happen to be able to do these in my head conveniently. Negative 10 squared is 100. 0 squared is 0. 10 squared is 100. And 20 squared is 400. Usually you're grabbing a calculator for this shit. And I bet most people in the room would need to grab a calculator for this stuff. But that's what they end up being. Then we're gonna add them up. We're gonna do the sigma part, is add them up. 400 plus 100 plus 0 plus 100 plus 400 is 1,000. So now at this point, we're at square root of 1,000 over n minus 1. We still need to do the rest of it.
Can you scoot the paper down a little bit, or up, I mean, sorry.
Yeah.
Thank you.
So n here, there's 5 entries, so that's n. So I'm doing 1,000 over 5 minus 1. Is 1,000 over 4, this is gonna be the square root of 250. I can't do that one. Then it's close to like 15.3 or some shit. Let's see, square root of 250. 15.8. If I were to round a 1 decimal place, it'd probably get 15.8. That would be S. That's what's going on by hand. Guess what? In StatCrunch. Stats. Summary stats. Columns. Same spot we just got the other stuff. If you do it in there, there's gonna be 2 entries that both say this. But one of them has UNADJ on it. These are both in the stats box. This one is for samples. And this one is for populations. And you will probably never use that in here. You won't use this much, if ever. You'll also see in StatCrunch something called variance. Variance is the standard deviation squared. So S squared for samples. Sigma squared for populations. And you will find. The larger. The standard deviation is. The greater the spread or dispersion of the data.
So, doing all of this, is this just like to summarize like an accurate amount of data? Like whenever we are trying to get a data and like represent it?
Yeah, if you've got a big data set and we want to represent it with just a few things. Mean and standard deviation for a bell shape. Will actually explain the way the graph looks. I'm about to show you why. So. Does anyone need this up longer? Okay. No, Alfredo, I was telling my wife that about the whole pasta thing. And she ended up going to Olive Garden with her friend on like Tuesday or some shit like that for lunch. And she brought me home some pasta. Do you know that she didn't fucking bring me no Alfredo? She brought me like five cheese ziti or something like that. So disappointed. Like, don't you fucking know I got an Alfredo in the class? Everyone good with this? Alright. So, the IQ test. The IQ test. The one that is like really the most official one. It's the first one. You can actually still do it at StanfordBenetTest.com. The population mean. So we're looking at mu is 100. Average score is 100. And standard deviation. Sigma is 15. I'm gonna try to do a nice good bell curve here. So the mean goes in the center. And we're gonna go out 3 steps to the side. 1 step to either side is right about where the graph is, just a little bit over halfway down. And once you've got that far out, you do about the same number of spacing for the next 2 marks. As you go to the right, you add 1 sigma at a time. So if this is 100, this is 100 plus 15, which is 115. This is 100 plus 2 times 15, which is 130. And this is 100 plus 3 times 15, which is 145. Guess what we do going the other way? Subtract, I didn't hear it, sorry. Yeah, we're subtracting. So same process. 100 minus 15, 100 minus 2 times 15. And 100 minus 3 times 15. And you get 85, 70, and 55. Now, this presentation I'm doing right now is called the empirical rule. Or sometimes empirical model. But it is a quick and easy thing that you can do as long as you know these 2 things. So it turns out. If we go between these 2 right here. Within 1 deviation plus or minus. This is 68% of the data. %68% of responses will be in this range. So that's between these 2. If I go between the 70 and the 130. This is 95%. So within 2 deviations. Plus or minus 2 sigma, we have 95%. Of the data is in here. And 3 deviations. 99.7%. Yeah.
So are we gonna try and like an exam quizzes, would we also have to solve for the range that's in that data, or is that just like a separate thing? that we have to do?
What do you mean?
Like when a question asks us, trying to figure out what is the range of responses within that area, and are we like?
Yeah, so it'll ask you what percentage of responses, sometimes it doesn't even do them where they're equally amount, so I was gonna actually show you guys the percentages in each range too. Chat box, I can't see what's on, okay, there we go. Mu plus 3 sigma right here. Mu minus sigma. Mu minus 2 sigma, mu minus 3 sigma. All right, so we said this region was 68%. That makes this region 34%. And this region 34%. The next wider category was 95%. Uh, 95 minus 68 leaves 27% to be split up between these two sides. 27 divided by 2 is 13.5%. So there's 13.5% in here and 13.5% in this region. $99.7 was 3. And that leaves just 4.7% to split between those two regions. 4.7 over 2 is 2.35%. So 2.35% there. 2.35% there. And outside that is only 0.3%, which gives us 0.15% on each side. The homework and Chip will ask you questions based on this. They might overlap it with values and say like, what percentage? We'll keep both tables up. On the IQ test, what percentage of people score between 70 and 115? $70 is at the -2 deviations mark. And 115 is at the +1 deviation mark. So if I look at those values, I've got 13.5 plus 34 plus 34% on each of these. I believe that's 81.5%. I didn't use a calculator there. So it'll ask stuff like that. It will not ask you for numbers that do not show up on an even increment of standard deviations until we go like chapter 7. Chapter 7, we start doing it another way. Until then, we're using this empirical model for all of our bell curve needs. And we can pretty much line any bell curve up on this. you just do the same thing with the mean, put it in the center, and you use the standard deviation, keep adding it as you go to the right, keep subtracting as you go to the left. And so like 95% of people are between 70 and 130. Because that's the middle 95%. I'm gonna show this graph again on Tuesday, because we're gonna use it a couple times. It's worth sketching it until you have it memorized. Other than that, get the fuck out. Have a good day, have a good weekend. Don't forget, Monday is a holiday, there's no classes on Mondays if you have a Monday class. Y'all fucked up, so the Tuesday, Thursday class, and you're stuck with me every day. I don't know if fucked up is the right word. Privileged, blessed to have David in your life 2 days a week.
Looking forward for Thanksgiving.
All right, Jesus, it's only been 3 weeks, and you're already fucking tired of me.